All right, so Priyanka says that she has done 2 projects in bioinformatics, including Schrodinger, Maestro, docking, and R programming also. And now she also wants to learn about machine learning. That's pretty interesting. And what about the rest of you guys? I'm curious to know about your background as well. How would you rate yourself? Are you a beginner in machine learning, or are you intermediate or advanced? How would you rate your proficiency in the field? I'm curious to know. All right, so let's start with today's webinar. Hello, everyone. A very warm greeting to one and all. My name is Sri Gauri Krishnakumar, and I would like to welcome you all for today's webinar on machine learning for health informatics. Health informatics is a rapidly growing field that involves collecting and analyzing healthcare data and creating new job opportunities where computers and healthcare providers work together. It's pretty closely related to the field of public health, and with the increasing use of big data analytics in the healthcare field, the demand for health informatics jobs are predicted to increase over the next decade. Considering the scope and degree of complexity in health informatics, we have designed the Machine Learning for Health Informatics program to skill up individuals who may come from the healthcare as well as data science domain. And in today's webinar, we are joined by Dr. Jit Sarkar, Senior Bioinformatics Scientist at LOS Data, who will be introducing us to the field of healthcare informatics. This will be followed by sharing of program details and the registration process. So before we begin with today's webinar, let me also take a brief moment to introduce you to the team behind the program. We are a US-based bioinformatics company who is working with multiple academic and commercial collaborators to develop easy-to-use analytical tools, and our mission is to make bioinformatics more accessible. And as a part of the program, students will have access to the Omoxrology training that has been completed by over 24,000 participants from 187 countries in over 300 workshops. And due to this fast growth, our team is working with local and regional coordinators that are helping refine local program logistics and adapting them to the needs of students and researchers around the world. And this training has been completed by participants in 6 different specialization tracks that includes oncology, infectious diseases, precision medicine, neuroscience, data science for biomedical data, and comprehensive training on omics data analytics. Students will also have access to the Omoxrology resources. Omoxrology is a portal for practical and theoretical learning of bioinformatics. It takes a combination of training modules, data analysis tools, curated project data sets, and interactive sessions with mentors to give the student a clear path up the Bloom's taxonomy pyramid. And no matter what the user's initial experience with bioinformatics is, Omoxrology is a useful tool for gaining a baseline knowledge of the theory behind bioinformatics, analysis of large data sets, and introduction to basic coding languages like R and Python, or even beginning a data analysis project. This also comes with an access to the Omoxrology courses, which includes courses on bioinformatics, precision medicine, multiomics that includes genomics, transcriptomics, metagenomics, epigenomics, data science that consists of using R and Python, as well as cheminformatics, and example projects of different fields which you could learn from and replicate for your research work. Users will also be given directions to access the T-Bioinfo platform for bioinformatic processing and analysis of data. The platform includes demo pipelines as well as data management and analysis cloud infrastructure to run the bioinformatic pipeline. And different stages of analysis are performed in different sections on this multiomics platform. So now, to view the various courses, example projects, student projects, you need to first sign up on the Omoxrology Learn portal. Before that, let me walk you through a brief demo on what a completed profile on the portal looks like. So once you have signed up on the portal, these are the features you need to update on your account. That is, the completed profile will have a profile image, full name with appropriate capitalization, link to your social media handles, a brief bio about yourself that will consist of your educational background and research interests. The mentors can view your progress under the Activity tab. The courses you are currently completing will appear under the Courses tab. Finally, after the completion of your course, the certificates will appear under the Certificates tab. So with that, let us begin by signing up on the Omoxrology Learn portal before proceeding with today's webinar. I'm sharing the link in the chat box for the participants to sign up on the portal. So for those participants who are new to the portal and want to create an account, you can simply click on the Create an Account option that you see here, and you can enter your name, email ID, and password. Or you also have an option to sign up using any of your social media handles, such as Google, Facebook account, Apple account, GitHub account, or even Twitter. And for those participants who already have a pre-existing account on the portal, you can simply click on the Login Now option that you see here and sign in. So with that, I'll pause for a couple of seconds for the participants to sign up so that I can show you the various courses and example projects and student projects that are there on the portal. And once you have signed up on the portal, please put a yes in the chat box so that I can proceed. I'm monitoring the chat box for your responses. If you're having any technical queries or so, you can leave that as well in the chat box and I'll be happy to help. All right, so Priyanka, Shruti, Suhasi has signed up. What about the rest of you? Has everyone signed up on the portal? Please put a yes in the chat box. And I'll walk you through the demonstration of how to navigate the portal. All right, I'm going to proceed along, but along the way, if you're having any queries, please feel free to share it in the chat and I'll be happy to help. So since I already have an account on the portal, I'm going to click on sign in option. So once you sign in, you'll be able to see the various courses that are there. So for those participants who do not have prior knowledge of bioinformatics, there are several introductory courses on bioinformatics that you can go to. Or if you have a specific interest, such as machine learning, you can simply enter the keyword that you're interested in, such as machine learning. That will show you the various courses and example projects that make use of the machine learning concept. So you can browse through and navigate at your own pace and explore the various courses that are there. So now moving on to the part that where you have to update your account. For that, you can simply click on the tab that says Welcome Back with your email ID. So once you click on that, you'll be able to see a profile icon such as this. So once you click on this, this will provide you with the options to edit your details, such as uploading your profile picture, editing your bio, adding your name, and as well as linking your social media handles. And as I mentioned before, under the Activity tab, the mentor of your program, as well as the community manager, will be tracking your learning progress. Under the Courses tab, you will be able to see the various courses that you are currently completing. Once you complete a project and publish it on our portal, you'll be able to view it under the Projects tab. And once you enroll for the programs, such as the machine learning for health informatics, that will appear under the Programs tab. After the completion of the associated quizzes and assignments, you'll be able to receive the certificates under the Certificates tab. So with that, I'll pause for a couple of seconds. All right, everyone has signed up. So if no one has any queries, let's move on to the next part of today's webinar. That is, I'm excited to invite Dr. Jit Sarkar. He is a physician scientist with a keen interest in data analytics and precision medicine. He's passionate about finding meaning out of biomedical data and leveraging them for better clinical outcomes. And his work generally involves offering meaningful and translational guidance to biological and healthcare organizations. Currently working as a senior bioinformatics scientist, I'm sure we'll be able to learn a lot from him about the field and opportunities that are present in the field. And with that, now I'd like to pass on the stage to Dr. Jit Sarkar. Over to you, sir.
Thanks, Sri Gauri.
Thank you.
Hey all. So let me go and share my screen. Is my screen visible?
Yes, sir, we can see your slides.
So once again, thanks Gauri for the opportunity. So as you know, today is the third webinar to introduce the course which we are going to start from the 11th of Jan, Machine Learning for Health Informatics. So in the last two webinars, we had discussed about the program overview and also the program background. Now, today's topic is mainly to introduce you to the hands-on training, which we will be having as a part of this particular course. So today's agenda, I will be covering a short recap of the last two webinars. Then I will just introduce the case studies, which we will be covering in the coming course, followed by a hands-on demo for the particular case studies. So just to recap about myself, so I am basically a clinician turned scientist. I started with my graduation and clinical residency about almost 6 years back, and then I shifted towards research, more majorly clinical research and bioinformatics research. For the last 2 years, I have shifted to the industry where actually I find meaningful insights from healthcare and biotech data using machine learning and other AI-based tools. So how data science is transforming healthcare in today's scenario? So as I already covered in the first webinar, so there are three major sections where healthcare in data science actually makes sense. The first and the most important is patient care. So now, how do we patient care? So how do we provide patient care? Patients are actually sort of a concentration of multiple types of data. So we can use that data, historical data, for patient care prediction, for risk stratification, for precise diagnostics, to detect a disease very early in the disease course, to do patient triage, and also for some imaging and diagnostic purposes. So these five mentioned are actually some of the use cases which we generally use for patient care. The next part is what you can see is business process and management. So healthcare domain contains lots of business processes and management, starting from hospital bed occupancy estimation to appointment management to claims administration to business insights. So these things also we can solve using healthcare data and by applying data science and ML models on healthcare data. Last and actually the majorly studied academic area is biotech and pharmaceuticals. So actually we can use healthcare data, we can use clinical trial data for drug discovery, for improving clinical trials to make them much more faster and swifter, and also to plan logistics. So there are multiple areas where data science is going to transform healthcare. So these three are just a glimpse or a bird's eye view of some of the use cases. Now, what solutions can we conceive in the domain of healthcare informatics? So here I have mentioned 6 big classes. So we can do prediction. So we can predict if a patient is going to have an incident of fall or an incident of stroke or an incident of hypoglycemia in the coming 1 hour, 1 week, or 1 month. We can cluster different patients as per their pathology and provide a much more precise therapy for a particular patient. Using remote patient monitoring devices like Fitbits and wearables, We can continuously stream the real-time data coming from our patient's Fitbit or the Apple Watch. And from there, we can predict a heart attack or sort of a reduced oxygen saturation before the event actually occurs. So image analysis, we can classify X-ray images, CT scan images. We can even classify video images using machine learning algorithms. Another thing is handwritten text analysis. So actually clinical notes contain very rich semantic information. Clinical notes are written by physicians, nurses, and administrators. So we can apply natural language processing sort of thing to extract insights from clinical notes. And we can merge multiple types of models to build a custom model for a specific use case purpose. To specify, so as I told that there is something called precision therapy. So there may be a group of patients, suppose hypertensive patients who are suffering from hypertension, or patients who are suffering from diabetes, or patients who are suffering from a particular breast cancer. Now, there can be different subtypes of that particular disease. So breast cancer may have different subtypes as per the genetic mutation or the genetic modification. And those precise clusters will be responding to very precise drug regimes. So identifying that precise cluster followed by administration of a precise drug regime is what we call as precision therapy in oncology. So this is one use case for health informatics. We can detect and classify tumors. So tumors from CT scan images, from MRI images, we can detect small tumors. We can detect skin lesions, skin tumors, and classify them as per their severity. Also, in the context of mental health, we can take multiple social network posts. Yes, Charles. So are we going to take questions now or at the end of the webinar?
It looks like he's unable to unmute himself. I'll ask him to share his query in the chat and we can proceed with the presentation.
Sure. And lastly, for mental health, we can use social network posts. We can do sentiment analysis to detect the level of depression, to detect anxiety from those network posts. So we can use almost each and every type of data, use a plethora of models to provide healthcare solutions. And for the next slide, I present here the different types of healthcare data. So this can be electronic medical records, which contains very rich patient, physician, and nurse interaction, and all the notes in a very unstructured way. We have medical images, we have slides, histopathology slides. We may have big volume multiomics data from, especially for oncology patients. We can have epidemiological data. We can have time series data. We can have clinical notes and social network data. So all these data types can be used in one or another way. Through using via models, we can generate insights to provide much more precise and coordinated care. So for this program, in the hands-on program, we will be discussing a brief introduction about the overview, background, and healthcare types, followed by some case studies, hands-on case studies. And this is how the case study structure would look like. So first, we would introduce you to the case study, what's the background and the objects of the case study. Then we will introduce the overview of data. So how does the data look, whether it's continuous, categorical, mix of continuous and categorical, the target variable, the predicted variable. And then we will do some data exploration where we will see the distribution of data, the type of data. If we need to change some data type, then we will do some model building where we will select the predictors target and the model which we will be building. Lastly, after we have built the model, we will do something called model validation, where we will measure the accuracy, sensitivity, specificity of the model. So there's something called true positive rate, then true negative rate, false positive rate, false negative rate. So those things we will discuss. And lastly, we will also end with model interpretation, something which is very important in healthcare informatics, where we will explain why and how the model predicted a particular outcome for a particular patient. So as I told, we will be dealing with two case studies. One case study is majorly using supervised learning. The other is majorly exploring unsupervised clustering. And the context is heart disease. So as you know, so just to mention, so almost the leading cause of mortality is cardiovascular event. So cardiovascular event means heart disease. So it's the biggest killer for both the sexes globally. Whatever disease you may be having, suppose you suffer from diabetes, suppose a person suffers from hypertension or a different disease, all the majority of the people eventually die with a heart disease, with a heart condition. And we also have some statistical and well-reported literature which has identified many risk factors which associate with heart disease. For this, in our course, we will be using the Cleveland heart disease data. So it's a very well curated and well structured data set. It's very widely cited and used for multiple data science purposes. We will do some feature exploration of the data. Then we will do some feature engineering, and then we will do some machine learning modeling. So this is just a glimpse of the data. I will also cover the much more specific thing in the hands-on demo today. So now let's go to the hands-on demo part. So any questions so far, or I'll just take a pause here.
We had a query from Kruti Rao. How could we connect ML or NLP to treat diseases like psoriasis?
Okay. So there are two questions, Kruti and Priyanka. So I guess this would be ML or NLP to treat diseases like psoriasis. Okay. So now first thing, Kriti and Priyanka, so it would be a bit more advanced answer to your question. Now, generally, so in the context of psoriasis, there are some there's a pretty much evolving literature which tells that all the so these are autoimmune diseases. So these are majorly autoimmune diseases. So what's an autoimmune disease? So there are some cells called T cells in our body, and the balance of immunosuppressive T cells and the pro-inflammatory and anti-inflammatory T cells is very finely maintained in our body. Only when this balance is not maintained, then there are certain T cells which starts to act against our own body. So it detects, so in a normal case, the antigen which our body has, this shouldn't be detected as a foreign antigen. But in the context of autoimmune disease, these antigens, the body antigens, are detected as foreign antigens. So this is the condition when the T cells start to inflame the body, some particular tissues, which can result in different autoimmune diseases. Now, for psoriasis, if you tell there is some leading information right now which tells that this is not a very homogeneous disease. So some person may have a particular genetic signature for psoriasis, some person a different signature. Accordingly, we should be able to cluster these patients from genomic data. And those genomic data, we can identify the genetic signatures which are very specific to a particular patient. And from there, we can devise much more precise therapy or a precise drug regime for a particular patient. So this is a very comprehensive thing, and maybe ML would fit into one part of multi-omics clustering in this context. For NLP, again, you are telling NLP. So NLP and ML is not overlapping. So NLP is actually a part of ML. So ML is a very big genre, and NLP mostly covers natural language processing. So it majorly tells with clinical notes. So you can extract. So what you can do. So there might be you might be having a record of patients of psoriatic patients. You might be having their clinical history. You might be having their lab information. And you can extract the clinical history, and maybe you can find out that different cluster of psoriatic patients present with different clinical symptoms. There you can also use NLP. So you can combine NLP with biochemical data, with multiomics to build a model. And this we name as multimodal modeling. So where we can combine multiple types of data using multiple different algorithms and come out with a solution. I hope I could answer your question. So so RIF, so can you please tell me what do you mean by RIF, Priyanka? Priyanka, you asked recurrent implantation failure. Okay, so in the same case, so implantation failure, I guess you are so implantation means are you telling about orthopedic implantation or some transplantation? So whatever is the case. So in the same case, implantation failure is again an immune failure sort of thing. So the body's implantation mechanism may be hampered. This may also fall in the context of pregnancy also. And so in that case, there again may be a particular genetic signature which is driving the failure. And if we can detect that genetic signature via some transcriptomic mechanism, that we can solve using ML or ML mechanisms. I guess I could answer your question, Priyanka. And next, Krishna Kumar has asked, is it possible to use ML in chikungunya and its post complications? So of course, so actually there is one word that there's one statement that you can model anything on Earth. Okay, so you can model anything, but what you need is a good data and a good model to capture your data. So of course, you can also model chikungunya and its post complications, but you have to generate the question specifically. You have to generate the objective specifically, and you have to generate the data and clean the data, structure it much more precisely, and then you can also do the modeling. Predicting pregnancy complications. Yes, this also can be done. This is actually done because pregnancy comes with multiple known complications, starting from hypertension, PIH, then anemia, and hypothyroid, and metabolic diseases, majorly GDM, gestational diabetes mellitus. And there is actually one very well sorted cohort which studies the risk of GDM among pregnant females. So you can take a group of females who had a history of pregnancy complications during pregnancy, and you can take their prospective data, their age, then their height, weight, BMI, and blood parameters. Then you can model and see that, then bring up and then define a model And this model you can use for a new patient to tell that this patient is having a risk of diabetes or PIH or anemia, like that. So you can also do that. Okay, so to build a good model, how much number of training data is expected? It totally depends on the question, and also there's something called internal and external validation. So generally, for a robust model, what we do is we build a model. So for any robust scientific answer, we do something called meta-analysis. So what it does, it combines multiple studies done across multiple locations, multiple labs, across multiple time, and combines all this data to get a particular information. For ML models, to build ML models, we do something called, we have something called discovery and validation. So suppose I take one particular data set, I will divide it into two sets, training and test set. I will build the model in the training set, and I will test it, and I will achieve a model accuracy. Then I will just apply the same model into an independent population, which is called the validation data set, and see if the accuracy is coming close to it or not. So the more the data, the more accurate it becomes. Otherwise, because healthcare is a very genetically driven domain, so models which work for Indian population may not work for the US population, which works for the European population may not operate for the African population. So there can be different other populations, and so it's best if we can build models and apply models to that particular population instead of jumping or training one model over population A and testing on population B. So it's a very population specific approach which we should take. I hope you got your answer. Okay, so if there are no questions, then we will go to the next section. So this is the hands-on demo, which I will walk through. So can you see my Google Colab tab?
Yes, sir, it is visible.
Okay. So for those who are not aware of Google Colab, I will just tell that, so it's an environment which provided by Google. So you can run Jupyter notebooks here, and you can run Python as well as R. And of course, you can run Bash in these code chunks. So you will see that there are two particular code things called code and text. So you can write text, insert images. You can also write codes and run the codes as some code snippets. So as you can see, I have in the table of contents here. So this is sort of the first case study which we will be covering, which I have named supervised learning, health, heart disease risk prediction. So we will use the Cleveland Clinic heart disease dataset, and we will be doing some supervised learning models using that dataset. So here you can see I have divided into 7 sections. So we will start with the introduction. And so where we will discuss heart disease and the potential risk factors. Then we will go to the data import, where we will import the data. We will convert different data types into different data types as per our question. We will do a very high level EDA. EDA means exploratory data analysis. It's the most important part of healthcare modeling or any modeling which you will do in your entire life. So never skip the step of EDA. And from the EDA, we will identify important clinical variables. Then I have called something as graphical EDA. So this EDA is more of a where we see the summary and where we see the data type and all those things. And then we will just graphically represent those EDA using box plot and histogram and pair plots, different things we will explore. Then we will go to the model building, where we will put some selected variables which we get from the EDA. to build a model, and then we will extract useful information from the model, and then we will explain the model. We will measure the importance of one variable over the outcome. Then we will do something called model diagnostic, where we will assess the model performance. By performance, I mean accuracy, sensitivity, and specificity. Then we will go to the last part, but the most important part, called the model explainability, where we will do the model interpretation. So so here, this is the table of contents. So here there's something called a folder. So we can add data either through some wget. So we can add data directly to this particular script using the bash or also the Python or code snippets. For this use case, I have the data saved in my particular system. I can also connect my Google Drive if I want. There's some option called mount drive. But just to tell you, if we are doing the particular modeling using R, in that case, the mount drive function doesn't work. Only if we are using Python, then we can mount the drive. In this case, I can upload the data from my system. So I am uploading the data from my system. So now you can see that the data has come here. Okay. So I can click on this to just see how does it look. But I won't be doing that. I will just importing it straight into my notebook. So now let's come to the notebook again. So it contains of these 7 parts. This particular slide tells you, so this I have shown before also. So it's generally the structure of how we build a supervised model from healthcare data. So we can have different data sources. We can do the data preparation. Then we can just identify the features using EDA. Then we can do the feature engineering. So we can transpose or translate or convert the features, normalize them. And then we divide it into 2 parts, training and validation. The training set will be used to build the model, and we will do the validation, and we will try to adjust the training and validation. And once it's done, we will arrive to a particular model, and this model we can customize by adjusting sensitivity and specificity. This is a very important step. I will tell you in the course, because in healthcare data we on many occasions we try to reduce the false negative cases. So false negative cases and true and false positive cases, there's a balance. If the false positive cases, if the percent of false positive cases reduces, then the percent of false negative cases increases, and the vice versa. But in healthcare data, we always try to minimize the false negative cases. We don't we generally are not concerned about the false positive cases, because we don't want any patient who has the disease to escape the model, to get reported as non-disease. So this is very important in the healthcare data. And then once the model is built, we can customize it. Then as we get new data, that passes to the model, and that gives you a prediction. And we can also explain why the model gave this prediction for this particular patient. So this is the pipeline or the workflow. Now let's, so as I have told, this is sort of an introduction, and this is a code snippet. So I have installed these, I have uploaded the data here. So you can see, if you can click on these 3 dots, you will see something called copy path. So you can copy this path, and you can just copy it here. Okay. And so this is the first function called read.table. So here we are just reading it. So it's a .csv. So means it's a comma separated file. So the separator is comma, and header equal to true means we are telling that in the first line of this particular file, you can find the header. Okay. So this is the header, and these are the information. So we can run this cell, and you have seen the head HD heart disease data. So it will print out the first 6 rows of the data set. So now you can see. So there are 6. Now this is the first 6 rows. So and it contains 14 columns. So the data set contains 14 columns. And if you see, there are the data types also. It's an integer, and these are double. So it's not an integer, it's a number, numeric, and these are all integers. So we will explain. So now the age we can. So it's the age of the patient. Sex is the sex of the patient. But what is CP? What is T-rest BPS? What is CHOL? What is FBS? So this needs some explanation. Now, again, as I told, for the data, there is one interesting story actually, that there was one particular new joinee in a company who was trying to increase the model accuracy. So the person was trying to increase the model, the data training amount, the training data. He was trying to put more data. He was trying to fit deep learning model, then random forest model, then so different models. But anyway, that person couldn't achieve a very high accuracy. Then that person came to a senior from the same company, and the senior person told him that focus more on feature engineering to select the features which may be important. And so then what the person tells in the next part of the story, that when I did the feature engineering and after data exploration, I could reduce the number of features, but I could achieve a very high accuracy. So what I mean to tell is that to build a very robust and very good model, don't focus on the training data, but focus on the feature. And this is where the domain knowledge or the understanding of the data comes in. So if you try to predict something by using a feature which has no role in the prediction, then the model would be actually underperforming. You always have to find out the domain knowledge. Does this particular predictor make sense in the prediction? Only when you are able to find out the important features, then only you will be having a very good model. Otherwise, even if you increase the data, if you try different models, you won't succeed. So that brings us to the next chunk, which is the understanding of the data. So here you can see I have given the name, type, and description. So here I explain the data, and from there you can also think, and you can also do some Googling or some research to find out that which models are important. Suppose age. So here we are predicting heart disease from age 6, chest pain, resting blood pressure, serum cholesterol, fasting blood sugar, exercise induced angina, and henceforth. So for heart disease, age is definitely a very important predictor. The more aged the person, the risk of heart disease is more. Sex is also a very important risk for heart disease. Now, chest pain. Yes, chest pain is absolutely a very important predictor for heart disease. So actually, because we are working with a clean data set, here you will be seeing only those predictors which are actually important. But in the real life scenario, you will be getting a very messy data set with lots of variables. Some make sense, some doesn't make sense. And from there, you have to clean the data set to find out those variables which actually make sense in the model. And from those predictors only, you will try to build the model. Okay. So after that, we will just discuss in detail about all these particular parameters. Why do they make sense and like that? Then there is something called data exploration. So here you can see that if you see the class, so class is actually what we will be predicting. So this is the outcome. So from all these features, age, sex, chest pain, then resting blood pressure, serum cholesterol, fasting blood sugar, and exercise induced angina, maximum heart rate, we will be predicting if the patient is having a heart disease. So for this data set, there are five classes. 0 means no presence. 1 means least likely to have heart disease. 2 is more than 1. So there is a higher chance of having heart disease. 3 is there is a more higher chance than having heart disease from 2. And 4 is there's more likely has heart disease. So for the sake to make the model very simple, we can club as no presence and presence. So you can club all the 1 to 4 to a single parameter and 0 into a other parameter. So for that, we can use a simple statement. It's a if else code. So if the class is greater than 0, then put all of them as 1, or else keep it 0. So here you can see class is 0, 2, 1 like that. So 2 and 1, both these things will be 1. And 0, 0, 0, both these things will remain 0. So 0 means no disease and 1 means has disease. And we are clubbing all of them together. So here for this particular, so we are creating a new variable in addition to the 14 variables. Okay. So, and these new variables we are naming as HD or heart disease. Okay. So here for this purpose, we are passing this particular data frame, heart disease underscore data. So actually it is a data frame, and I guess all of you have at least some knowledge of R. If not, then I would suggest you to go through a very introductory R course, just having a knowledge of some basic packages, base R, dplyr, tidyr, and ggplot. That would be enough. So here you can see this is a data frame object. So R treats variables as objects. So it stores variables as objects. And here, so this is an object, and the call names we can print as call names data, and these are the call names. Okay. So we will be creating a new call name called HD. And for this, we will use the function called mutate. So mutate actually appends a new column using this logic. Okay. And this mutate, to run this mutate, we have to install a package called tidyverse. Okay. It's a very versatile package containing multiple packages. So I have the code, I'll just run it. So now if suppose I run this, you will see there is a additional column called HD. Okay. And we can also see this particular, let's print out the first 6 rows, and you see that is a new row. So here you see 0 is 0, but 2, 1 have been 1 and 1. So we are reclubbing this. Okay. Now suppose I want to see that what are the number of patients in these 2 groups. Okay. So I can print. So now you see this is a double. Okay. So if I print the summary, it will give me a mean first quintile, median, mean, third quintile, and max. So because it's an integer, HD is an integer, it gives me a summary of integer. So I have to convert them into factor. Okay. So this I can convert using factor. And now you can see I have 164 cases of no heart disease and 139 of heart disease. Now, actually for this data set, clubbing them into these 2 particular groups as 0 and 1 makes more sense. Why makes more sense? Suppose I didn't club them. So if I hadn't clubbed them, so it would be class is what I guess. So there are 164 has 0, 155, then so it's decreasing, and 4. So when I do the model, there are much more samples having no heart disease, and there is very low sample having the highest category of severe heart disease. So this is something called data imbalance. So we are having imbalanced data. So why is this a very tough thing? Because if we are having data imbalance, then when we build the machine learning model, So a machine learning model learns from the data. Now, because we have much more samples in the no heart disease category, it will learn more from this particular category, and it will learn less from the severe heart disease category. And that will lead to a very unfair model performance in this particular class, the fourth class. So there's something called recall and precision. So, and there's something called a matrix. So when we draw the matrix, we will be finding that maybe a very few patients in the fourth group would be accurately predicted, because the model had seen very less data, only 13%. So it would be performing very low in this particular category. Okay, so for this particular reason, we are clubbing it. Now it's actually more of a balanced data set. So we have 164, 139. So it will be performing good in both the classes. Okay, so these are some things, or some sort of techniques which we actually use in real life scenario. We could have also clubbed it into 0, 1, and 2, where we put, suppose, the 0 as 0, 1 as 1, and 2, 3, 4 we club into the. So we club as no heart disease, mild heart disease, or heart disease, like that. So that also makes a very balanced, not this much balanced, but still a balanced data set. Now, the next part we will be going is through the exploratory data analysis. So as I told, we will be exploring the data. EDA mainly contains of some statistical tests. So there are some tests called t-tests and chi-square test and Wilcoxon tests. Different tests are using for different types of variable. So suppose in this case, I am just implementing a chi-square test. So I will actually compare. So sex is the predictor and HD is the heart disease, 0 or 1. Okay. So I can also just I can just show you how it looks. Table. So this shows you, so 0 and 1, I guess 0 is female and 1 is male. We can see from the data dictionary. And so this 0 is, this is sex, and this is, let me print it. Okay, so 0 is sex. And so female, there are 72 females with no heart disease, 25 patients with some heart disease, 92 male patients with no heart disease, 114 with some heart disease. So from this simple exploration, you can see that 72 females are having heart disease and 72 no heart disease, 25 heart disease. On the other hand, 92 males, no heart disease, but 114 heart disease. So this, from here, I can infer that sex is actually a predictor of heart disease. So so males have more chances of having heart disease compared to females. I can infer this particular statement if I consider that the data collection and all these things have been randomly done, there is no bias. If I consider that thing, so considering that the data collection procedure has been done using random sampling or following proper data collection procedures, I can tell that males have a higher risk. Now, so this is, I can tell from just a glimpse or just an overview. But if I want to statistically confirm it, I can use something called chi-square test. So this chi-square test is the function is chi-test dot test. I will pass these two particular vectors. So what does vector mean? So HD underscore data is a data frame, and $6 is actually a column. So one column, if I if I cut from a particular data point, it's a vector. So I can give two vectors, and this vector gives me something called I'm saving as HD6, and I'm printing it. So it tells me that Pearson's chi-square test with Yeats continuity correction. The data is like that. The x squared is this. The DF is 1. So DF is the number of the degree of freedom, and the p-value is less than 0.05. It's actually much less than 0.05. So this tells me that sex is a very important predictor, and sex actually has an influence in predicting heart disease. So this is for the categorical variable, sex and heart disease. But if I had age, so age is not a category, age is a continuous variable. In that case, in this case, I would have used something called t-test. Okay, so before I go to the so I can just explore age, and I can just draw a histogram, and you see this tells me the histogram. It gives me the distribution of the patients, and actually it's a very good and very it's a normal distribution. Again, there's something which we visualize, something we can test using the statistical test. So I can, from my visual inspection, I tell that this is a normal distribution. Again, for testing normality, we have Shapiro Wilk test. We can do a QQ quantile distribution. There are lots of things which we will also discuss in the. There are lots of techniques. So we can see and we can infer. We can do the statistical test and we can infer. So there are two approaches, and both should be done to confirm the result. Okay. So for this, actually, we use something called t-test. So just we can write t-test here, and here would be age, and I haven't changed it, so I will just change it as age. And so it gives me a Welch 2-sample t-test, and you can see that the mean of X is 54. So the mean and the mean of Y is sort of so 52 is 52 and 55, and here also this is just okay. And this p-value also tells that it's a very significant variable. So that means that with age, the chances of developing heart disease is also increased. So age is also a significant predictor. Again, in this particular data set, we have already cleaned the data set and taken those particular predictors which are actually important. So if we do the individual exploration, we will get all the variables to be important. But in real life data, we should be doing all these things to select the important predictors. Okay. So this is for the EDA. Now graphical EDA. So this is also graphical because we are doing some graphs out of this. But again, we can suppose now 0 and 1, 0. So we are again relabeling just for the sake of good understanding. Suppose here we can record and we can plot the age. Now you can see that for the disease, the median age is much higher. For the no disease, the median age is much lower. Okay, so almost the median age in case of no disease is close to the first quantile of the disease. So it's definitely significant, and the t-test also tells us it's significant. So we can do some graphical exploration. So in this case, we are doing a box plot because we have two categories. One is categorical, disease, no disease. One is continuous. If we had two continuous, we would have done a pair plot. If we have both categories, then in that case, we will have done a heat map or with a chi-square test. So we will be exploring all the variables, and I will also explain the cause, and we will also refer to some standard literature which tells and which actually confirms our finding. So it's sort of a literature as well as data. So it's not that data is the gold standard. We also have to consult the literature. We also have to consult the domain experts, and only then can we be sure of our results. And then we will take the important variables to build the model. So we have different models. In this case, we will start with a very easy and the most widely used model, generalized linear model, logarithmic model. And we will build the model. Then we will extract the summary. We will extract the useful information. Then predicted probability. I will explain why probability, what is probability. So the intent is to tell that if you are having 1 year more of age, then what is the, how much, by how much percent you have a higher risk of developing heart disease. So if you are a female, and if you are a male, then compared to a female person, how much is the increase of your heart disease risk. So we also have to quantify this particular risk. So this quantification we can do using some classical models, which are called generalized linear models. And there's also something you might be hearing that there's something called a black box machine learning. There's something called interpretable machine learning. And there's something in the between. So GLM, these models, and there's something called tree-based models. This help us to interpret the model, but this can't handle complex data. On the other hand, deep learning models and random forest models and extreme gradient boosting models, they are black box models, but they have some limitation in interpretation. Okay, but nowadays people are also coming with new techniques to interpret even the black box models. So we will build the model, we will explain the model, we will quantify that if you are a male compared to, and so then compared to a female, what is the higher risk of your getting heart disease. If you are 40 years, then compared to a person of 30 years, how much is your risk more than to develop heart disease. And lastly, we will do the model diagnostics. So we have, suppose, 100 samples, then we will run the model over all the samples. Then we will find that how many the model has predicted right, how many wrong. And there are certain metrics called area under the curve, then sensitivity, then specificity, recall, precision. We will discuss, and classification error. We will discuss all these things. And lastly, we will go through some things called model explainability. So model explainability actually tells you, so if you give a new sample to the model, it will give you a prediction that this person is having a risk of 60% of developing heart disease risk. But why did it tell 60%? So the model explainability algorithms will also tell you that this person is going to be is having a risk 60% of developing heart disease because this person is a male, this person is a smoker, the mean cholesterol of this person is above average, and this person is complaining, is having dyspnea or distress on exertion. So this will also tell you the causes. And these causes actually helps the physicians and the nurses to take decisions, because now they also know that why the model has predicted this particular thing for this particular patient. It gives more confidence. It helps more model acceptance and adoption. So it's a very important topic in today's time, and we will also explain model explainability as the last section. So I guess I will stop here today for the hands-on demo, and I can take questions if there are any.
Thank you so much, sir. We do have a query from Muku Bandari. He's asking, do you have this notebook we can use side by side? And do we also customize the overfitting?
Yes, so Srigauri, I guess we will also be will they also be doing this side by side during the hands-on demo, or it will be a sort of a homework or a sort of a assignment.
All right, sir. And he's also asking, do we also customize the overfitting?
So overfitting, so customizing overfitting is actually customizing the true positive, false positive, and false negative in terms of healthcare informatics. So overfitting means when the overfitting means when the model is performing very well in the training data and very not performing in the test data. So we will also customize overfitting. So this will fall under the model performance evaluation, and from there we will again go to the model building. Yes.
Thank you, sir. And do we have any further queries? I'll pause for a couple of seconds. All right, sir. It looks like we have no more queries. So thank you so much, sir, for joining today's webinar and taking up the participants' queries. I'm sure that the participants were able to learn a lot about the field and from your excellent presentation. We look forward to learn more from you during the course of the machine learning program. And with that, now I'd like to invite my colleague from the marketing team who's sharing more about the program registration. So over to you, Shubham.
Yeah, thank you, Sri Gauri. So, hello everyone. Myself Shubham. I am the just a second. First, let me share my screen. Yeah, Sri Gauri, can you confirm? Is my screen visible?
Yes, we can see your screen.
Okay. So, hello everyone. Myself Shubham. I am the marketing and business development here at Pine Biotech. I'll be quickly briefing you about the registration part for machine learning for health informatics case-based learning program by Dr. Jit Sarkar. So as you can see, this is our the program page. So let me share the link of this program page first. Yeah, so you can go through this link after the session. So this is a program page, machine learning for health informatics case-based learning, and it will commence from 11 Jan. So very few days are left for the enrollment. So I would request you to please hurry up and enroll for this program. As you will scroll down, you will see the program overview of this program. So in this, you will get to know about the topics and the concepts which will be covered or after the program, what you will be learning from this program. So it includes like case-based learning for the data science and machine learning, as well as the mentor guidance from Dr. Jit Sarkar. Then the beginner to advanced level of all the topics like data acquisition, data structuring, workflow selection, and cross-validation for healthcare and clinical data analysis. You will also get to know about the analysis of data types, then various opportunities for participants in various fields of for jobs or internships, or if anyone wants to gain experience also. Along with that, we will provide you the career guidance and the certification after the program. So below, as you will scroll down, you will see an interactive calendar in which you will see few dates are highlighted. So on that particular dates, we will be having a live sessions. And on the right hand side of that calendar, you will see the topics which will be covering, which will be covered in that particular session. So like you can see here, like the heart disease and risk factor, as today Dr. Jeet Sarkar has said in told about the using the Google Colab. Along with in the next session, we will be covering the data and analysis part and some of the example overviews. So further down the page, you will get to see that we have three different tenures for this program. One is 45 days, 60 days, and 90 days. So you might be thinking about the differences for these three different tenures. So first of all, let me tell you the common resources which are there for these tenures. So the common resources are like you will be getting the online tutorial, then project examples from our Omoxrology clone platform. You will also get the coding sessions, hands-on coding sessions. And by chance, if you miss any session or like the lecture, then we will provide you the session recording as well. Along with that, you will get the online mentor support and the online technical support from our team. And after the completion of this program, you will definitely get a certificate of completion. Now, the difference between these three tenures are like for 60 days, you will get an opportunity for one-on-one mentor session. Along with that, while going through the courses, if you pop up with any of your research idea, then you can propose your research question. And even though you can like present a research poster presentation on various international symposiums, and in the 90 days tenure, you will get a golden opportunity along with the one-on-one mentor session, and like along with mentor session, you can complete your independent research project work and get it in the published in the peer reviewed journal. So these are the difference between the 45 days, 60 days and 90 days tenure. Now coming to the pricing part, so as you can see, like for in USD, we have the pricings are dollar 150, dollar 300, and dollar 450. If anyone like, you can see a drop down option here on the top right corner, where you can select the currency based on your location. So as we are in India, so like for Indian participants, the pricing is 7,500 for 45 days, 9,999 for 60 days, and 14,999 for 90 days. So currently we are providing the scholarship of 50% for all three different tenures. So I will be sharing with the steps to enroll along with the coupon code. The coupon code is health50. So let's say if I want to enroll for the 90 days program, then you simply have to click on buy now button, and you can type here the coupon code, which is health50, and everything is in caps. And after that, just click on apply. So you can see coupon is applied successfully, and you will see the reduced price of 50%, like that is 7,500 or 7,499. And after that, you just fill your details and select the payment method. So yeah, so this is the registration part. If you have any query regarding the registration part, please feel free to message to type in the chat box. But by the time I will be sharing with the steps to enroll. Yeah, thank you, Sri Gauri, for sharing the details.
Thank you so much. If participants have any queries, yes, we do have a couple of queries. So Mukesh is asking, where will we get the coupon code?
Yeah, I am providing you the coupon code. The coupon code is health50. Health50.
Thank you so much, Shubham. And yes, Shubham.
So I think Chirag is asking, I have paid for the course. What next should I do? So Chirag, a team will message you about the sessions when we will be conducting the live sessions. You will get a calendar invitation. On that particular time, you can join for the live session. Enroll for 4 month internship. Should I have to pay for it? Priyanka, I think you have paid for the research fellowship program. So this is a different program, which is like machine learning. So if you want to enroll for this particular one, then you can mail you can enter your mail ID. Then we will share you the details on how to enroll for this particular program.
Thank you so much, Shubham. Does anyone have any further queries? I'm sharing the email ID of our marketing manager so that along the way, if you're having any queries, you can mail as well. Kesh is asking, what is the last day to enroll for the program?
So the last day to enroll for this program, as you like, it is enroll starting from 11th. So on 15th, the coupon code will expire. So I would request to enroll before 15th to avail the offer of 50%.
Thank you so much. So if the participants are having no further queries, we will be ending today's webinar. All right, then thank you so much everyone for joining today's webinar, and we look forward to seeing you at the program as well. Have a great day. Thank you, everyone.